Today we are learning about variation. First is direct variation. If y varies directly as x and there's some non-zero constant k such that y equals k times x, that is what direct variation is. So the value of one variable is a product of a constant and the other variable. And in joint variation, y varies jointly as x and z if there is some non-zero constant k, such as y equals k times xz. So the k in both of these situations would be called our constant of variation. So example 1 says, if y varies directly as x and y equals -3 when x is 24, find y when x equals -16. So I start by writing the formula for direct variation, y equals some constant times x, and then I'm going to substitute in the given value, y is -3 when x is 24, and then we can solve for k, which is our constant of variation. So I'm going to divide both sides by 24, and now that I know the constant of variation, I can write the equation, y equals -1/8 times x. And then we can find y when x is -16 by substituting -16 in for x, and we get y equals 2. Example 2, suppose y varies jointly as x and z. Find y when x is 4 and z is -3. If y equals -15 when x equals -6 and z equals 1. So I always start by writing the joint variation formula, and then we'll substitute in the given information. Y is 15 when x is -6 and z is 1, and then we can solve for k. So I'm going to divide both sides by -6, and our constant of variation is 5/2. So now that we have this equation with the known constant of variation, we can find y when x is 4 and z is -3. So substitute 4 for x and -3 for z. So that would give us y equals -30. Another form of variation is inverse variation. Y varies inversely as x if there is some non-zero constant k such that xy equals k, or y equals k divided by x. If x times y is 8 and x equals 12, then y equals 8/12 or 2/3. If m varies inversely as n, so I'll start by writing the inverse relationship. If m varies inversely with n, m equals a constant of variation divided by n. M equals -4 when x equals 6, so substituting in the given values. To solve for our constant of variation, we would multiply both sides by 6, and we get our constant of variation is -24. Find m when n equals -10. So then replacing n with -10, we get 2.4. Inverse variation and combined variation. If you know that y varies directly as x and that y varies inversely as z, one set of values, you can use a proportion to find another set of corresponding values. So this proportion right here, y1 times z1 over x1 equals y2 times z2 over x2. Suppose a varies directly as b and a varies inversely as c. Find b when a equals 6, c equals 28. If b equals 7, when a equals -49 and c equals 3. So starting with a1 equals a constant of variation times b1 over c1. For the second values, we have our constant of variation times second b divided by second c. So to find our constant of variation, we have set up this proportion. So a1 times c1 over b1 equals a2 times c2 over b2. So substituting in all the given information, we have 6 times 28 over b1 equals -49 times 3 over 7. And then we can solve this using cross product. So -147 times b1 equals, and I multiplied 168 times 7. So the cross products are equal in a proportion. And then to solve for b1, we would divide both sides by -147. So we get -8. So when A is 6 and C is 28, the value of B is -8. Example 5. A rider's speed in miles per hour varies jointly with the revolutions per minute of the pedals and the number of teeth on the front gear, and inversely with the number of teeth on the rear gear. On a flat stretch of road, a rider is traveling 17.1 miles per hour using a front gear with 50 teeth and a rear gear with 16 teeth, pedaling at 70 miles per hour. Find the speed the rider when she bikes uphill using a front gear with 34 teeth and a rear gear with 23 teeth while pedaling 70 miles per hour. So our proportion will be x1 times r1 over p1 times f1 will equal then our second set, x2 times r2 over p2 times f2. So substituting in our given information, 17.1 for x, 16 for R1, and then 70 for P1 and 50 for F1. And then 23 for R2, 70 for P2, 34 for F2. Simplifying that leaves us with this expression, and then we would set our cross products equal to each other, and then solve for x2. Divide both sides by 575, so we'd get about 8.1. Thank you for watching.